And we move on to addition and subtraction with radicals. So what I want you to feel when you're doing these is the same thing you would feel when adding like terms with variables. 2x plus 3x, you are just adding the coefficients, bringing over that variable. It's going to be 5x, right? Add 2, add 3, x's stay the same. Boom, that's it. Radicals work the same way. 2 radical 5 plus 3 radical 5 is equal to 5 radical 5. Again, it's the radical that's acting as the x in this case. And we're adding the coefficients. 2 plus 3 is 5. And the radicand stays the same. Okay, that's it. We're looking for like radicands, right? The numbers on the inside. We can't add them together if those are not the same number. So similarly, radical 11 plus 6 radical 11 would be 7 radical 11. Why? Because there's an understood 1 as the coefficient on that one. We can do 4 radical 5 minus 3 radical 5 plus radical 5. Can you figure out what that one would be? Do all of your radicands match? Yes. 5, 5, 5. So we can add all of the coefficients or subtract. In this case, it's 4 minus 3 plus 1. Well, that's going to be a 2. 2 radical 5. Okay. So in all those situations, I gave you like radicands. I gave you numbers that were the same inside the radicals. They're not always going to be like that. Sometimes you just have to simplify them first, and you know how to do that. Let's do the square root of 8 plus the square root of 18. Obviously, these numbers are not the same, so we cannot add them yet. We need to simplify first. Simplify them. How do we do that? We take the 8, we break it up into 4 times 2, because 4 is a perfect square. What is its perfect square, or what is its square root? 2. So we change it to 2 radical 2. We do the same thing with 18. We change it into 9 times 2, because 9 is a perfect square, whose square is 3. So we bring that 3 out front, and it's now 3 radical 2. So again, notice they both had this 2 as a factor, and those 2's stayed on the inside. So now we can add them. Now we can add them, adding the coefficients to make it 5 radical 2. So we simplified first, and then we added those added those coefficients. Okay, how about this one? 2 radical 27 minus radical 75. Maybe you pause the video and try this one on your own. I'll keep going. So we have 2 here. I'm going to focus on this first radical. 27 is 9 times 3. Then I've got my 2 times the square root of that 9 is 3, so that comes outside, and I still have a 3 left over, which makes this 6 radical 3. Minus 75 is 25 times 3. This is a perfect square. Its square root is 5, which makes it 5 radical 3. So we have 6 radical 3 minus 5 radical 3. Now, 6 minus 5 is 1, but if that's all we have, we don't even write it. We just say that's equal to radical 3. Okay? Number 3, try this one on your own. Square root of 45 plus the square root of 80. Again, pause this video and try this one on your own. 45 is 9 times 5. Square root of 9 is 3, so we can bring that out front. Not 3 radical 5 plus 80. Do you remember what perfect square is inside 80? Hopefully you came up with 16 times 5. 16 is the square of 4, so we'll bring that 4 out front. The with the radical 5 still on the inside. Again, just as we've seen before, both of these had a 5 that stayed on the inside. Those are like radicals, and so we add the coefficients, 7 radical 5. And now we're going to put in some variables. We haven't seen variables yet. Square root of 27y plus the square root of 12y. Again, try this on your own first. See if you can figure out how this goes. I'll keep going. What we have here is 9 times 3y. Here's a perfect square. Bring it outside. Right? The square root of 9 is 3, so that comes out. This 3y stays on the inside. You can even think of it as 9 times 3 times y. Neither the 3 nor the y were perfect squares, so they stay inside together. Plus, well, 12 is 4 times 3 times y. 4 is the only perfect square. Bring out the 2. And 3y stays on the inside. So they are like radicands, right? They've got the same things on the inside. They just happen to have a variable. We're adding the coefficients. 3 plus 2 is 5. And again, as before, the radicand stays as it was, 5 times radical 3y. Last one. Again, try this on your own. The square root of 27x to the 5th, that's all under that radical, plus 7x times the square root of 48x to the 3rd, right? This one's a bit more challenging. See if you can do this on your own. Simplify these as much as possible first. So I'm going to keep going here. So this, I should really be putting equal signs out front here. This is equal to, so 27 is 9 times 3 times x to the 5th is x to the 4th times x to the 1st. We need the biggest possible multiple of 2. What are my perfect squares? The 9, the x to the 4th. So I can bring those out front as 3. And then half of this exponent is x squared. So 3x squared comes out front. What stays inside? 3x. So just check that over. Make sure you're okay with that. I'm going to move on to this one. Plus, we know we have 7x still out here. 7x times, we're going to bring something out there with it to figure out what that is. 48. Did you come up with that this is 16 times 3? Times, and did you remember what to do with this? X squared times x to the 1st. That's the biggest possible multiple of 2. So again, our perfect squares are 16 and x squared. We got plus, we have our 7x out here. Now we're going to multiply that by 4 from here. And the square root of this is x, so also another x. What's left on the inside? 3 and x. Now I need to tidy this up, right? This says 7x times 4 times x. It's also 7 times x times 4 times x. But we need to just tidy that up, simplify it. 7 times 4 is 28. X times x is x squared. Sometimes we just need to clean things up before we move on. Just bringing this down. Okay. So what do we notice? We notice that our radicands are like, which means we can add the coefficients. But also notice that the coefficients have variables in them. Those would also have to be like terms, and they are. 3x squared plus 28x squared is 31x squared times the square root of 3x. These just stay the same. And that is how we add and subtract with radicals. You have to just have that same number in variables, same expression on the inside of the radical.